Goodness. All right. It says, on a math test, students earn 4 points for each correct answer and lose 1 point for each incorrect answer. There are 50 questions on the test. A student's score is shown by the expression. All right, so the first one is 4 times 50 minus W minus W. And the second one is 5 times 40 minus W. So you have to distribute. So 4 times 50 is 200. 4 times W is minus 4W plus the negative W here. So this would give me 200 minus negative 4 and negative 1 is negative 5W. To the second equation, distribute again. Well, 5 times 4 is 20, right? So that's 200. And then 5 times W is negative 5W. So are they equivalent? The answer would be yes, they are equivalent. You are welcome. Kylie, were you able to see the on your own questions that I just did for you? Okay, so I don't know, Kaylee, I'm not sure why. Let me reshare it. Hold on. All right, so hopefully that helped. All right, so someone said number 3. All right, so believe it or not, those are fancy little L's. They're not E's. And we're also talking perimeter. So perimeter, remember, is 2 times W and 2 times L, which is the length. So they want us to combine our like terms. Okay, so we're going to use properties first, right? So if it's L plus W, to get to L plus W plus W, we rearranged. So when we rearrange things, that is the commutative property. Okay, so we're going to combine like terms. So L plus L is 2L. And W plus W is 2W. Okay, so we're going to undo the distributor property. So we're going to factor. So that means I'm going to divide each one by 2 because I'm factoring. So it leaves me with L plus W. Number 10. Okay, so remember I said you can only add terms that have the same variable and the same exponent. So that means I can only add the p to the third and the p to the thirds. So remember there's an imaginary 1 there. So it's 6p to the third plus 1p to the third, which gives me 7p to the third, and then I just bring the 2p squared over. You have to use the distributive property first, or you can actually just substitute in 2. But if I distribute, it says Marcus wrote the expression 7 times x plus 8. Liz wrote a different expression that had the same value as Marcus, expressed when x is 2. What could Liz's expression be? Well, if x is 2, I just substitute in the 2. So we want the same value of 70 is what we want. Okay? So Liz's expression could be a variety of things. It could have been, because this gives me 7x, right, plus 56. So it could be 3x plus 4x plus 56. That could be something. This would be Liz, right? Yeah. Heck, she could have just done 7x plus, I don't know, 50 plus 6. So there could be a bunch of different combinations for her equation. Okay? But as long as whatever I'm substituting in gets me to 70, you'll be okay.
This Lavelle.
Yeah.
Can I have help on number 6?
Yep. Okay, so it's the same thing. It says, what property of operations is used to show that 12x plus 6y is equivalent? So anytime we have something on the outside, what property is that? What am I doing?
You have to multiply the inside the parentheses.
Right, so what is that property called? Starts with a D.
Distributive?
Yeah. All it's asking you for is the property.
Oh.
So Sarah earned $7.50 an hour babysitting. So 7.5 per hour, because we don't know how many hours. She also earns $5 an hour for walking dogs. Last week she worked 8 hours babysitting and twice as many hours walking. So that means we're going to take this one and multiply it by 2. So 7.5H plus 2 times 5 is 10. So 7.5 plus 10 is 17.5H. Once again, the variable and the exponent is the same. So all you have to do is subtract the 8 and the 3. So what do we get when we subtract the 8 and the 3?
We get 5.
Yeah. So it's just 5W squared. All right, and then on number 12, you got to do some distributive property. So we got to distribute first. So 4 times G and 4 times 2. So what do I get?
4 times 2 is 8, and then 4 times G would be just 4G.
Yep. And then I got to come back and add the 3 and the G. So 4G plus G is what?
4G plus G would make 4G to the second power, or?
No, remember there's a 1G here.
Oh, that would make 5G.
Yeah. And then I just add the 8 and the 3. What do I get?
The 8 and the 3, that would make 11.
Yep.
So the answer is 6G.
No.
Or 16G.
Can I add the 11 to the 5G?
Oh, no, because that doesn't... No.
Yeah, the 11 doesn't have a G, so I can't add it.
So that's the end.
That's the end.
Okay.
All right, Clementine, see you tomorrow.
I need help on 9. It's a bit confusing.
You don't have to do 9.
Oh.
But how is that confusing? 7x and 1x. Just add them together. Y'all make things harder than what they really are. Well, I feel like I've done everybody's on your own for you today. All right. This is the expression, the original expression. So if I distribute, I get 6 times 2, which is 12n, plus 6 times 3, which is 18. So we are trying to get these statements to be the same. In order to do that, we have to add a 2n. So if I add a 2n, I end up with 14n plus 21. That one doesn't work. If I add a 2n, I end up with 2n plus 19. If I add a 2n here, this gives me 10n plus the 2n, so that gives me 12n. And then 2 times 9 is 18. And in this one, if I add a 2n, I get 14n plus 1. So this one is the one that works. All right, thank you. Have a good day. All right, so we're trying to see if the expressions are equivalent. So if we do this, do we get this? So we're going to multiply 1/4 times 8 over 1. So really, it's just 8 divided by 4.
Which equals 2.
Yep, so that would be 2j. Plus, same thing, 1/4 times 12 over 1, which is really 12 over 4.
Equals 3.
Yep, which is 3k. So is this and that equivalent?
No, ma'am.
Nope. So just write not equivalent.
Okay.
Okay?
Thank you.
No problem. All right, so number 18, the same thing. It says determine whether the expression 6x plus 2 plus 4x and 8x plus 4 have the same value when you substitute in 2. So you're going to substitute in 2. So 6 times 2 plus 2 times 4 times 2. And then 8 times 2 plus 4. Okay, and I'm not going to multiply all that out. You should be able to multiply it and figure out if they're equivalent.